Okay, problem number 12 says determine if the function is continuous. If the function is not continuous, find anywhere where it's not continuous or where it's got discontinuity. So, and tell me what kind of discontinuity it has. So, first of all, can you put in any number? Continuous means that like any number can be put in and the graph will be smooth, right? There will be no breaks in the graph. So if you just think about it, there's only one number here that presents a problem. It's a number like this that would produce 0 on the bottom, right? So that would be x equals 1. So there is discontinuity at x equals 1. And now what kind of discontinuity is that? Well, if you put 1 into the top, you get 1 squared is 1. Okay, well, that's not a hole. That's an asymptote. So that's a vertical asymptote, and that is non-removable discontinuity because you can't easily fix an asymptote like that. That's like how we try to, the analogy is, you know, if it's a hole, you can plug the hole really easily, but not on an asymptote. Okay, number 13, same directions. Is this whole function continuous? Well, I don't know. I mean, when I look at it, I'm thinking, wow, that's kind of a lot going on there. Why don't I factor? It's hard to tell if there's any numbers that'll mess up the bottom or the top. So the bottom factors x plus 2 and x plus 2. And so now it's a little bit more obvious that I can plug in any x values I want, except for x equals -2 would produce 0 and a 0. It would basically produce -2 on the top and 0 on the bottom. So that's a problem. That means that this right here, that there is discontinuity at x equals -2, and it's a vertical asymptote, so it's non-removable. Non-removable discontinuity. Okay, so 14. Can I put any number I want in here? Well, because of this squared and the plus 2, right? So any number I put in, and when you square numbers, when you square a number, it becomes positive. So that basically means I'm going to always have, and then I'm going to add 2, I'm going to have a positive number on the bottom and 4 on the top. So I'll always get an answer. So you're going to say this is continuous. The entire problem is continuous. There's no discontinuity. Okay, so polynomials like this, they're always continuous. Right? They always are smooth. Like if you graph them, you can put any number in you want, though all numbers you put in will work. Okay, continuity on 16. Well, I don't know. I probably should factor the bottom. Maybe it'll help tell me something. So factoring the bottom, you get x plus 3 and x minus 1 and x plus 7 on the top. So there's no common factors top and bottom. So I guess I could think of a number x, if I plugged in -3, that would be bad. And if I plugged in 1, that would be bad. It would produce, both of those would produce a number up top and 0 on the bottom, which means they're both vertical asymptotes. So there's discontinuity at x equals 3 and x equals 1, and they're both non-removable because they're both vertical asymptotes. Okay. Finally, 17. Is this continuous? Well, I don't know. Take a look at the top here. Let's see if we can factor it maybe. So if we factor the top, what do we get? X plus 2 and x minus 1. So this is a different type of discontinuity. If I foresee a problem if you put in -2 here, and you put -2 in here, and in here, you end up with 0 over 0. So this is, we've seen this already by doing this homework. There's a hole in this problem, right? So a hole is discontinuity. So this has discontinuity at x equals -2. But this time, because it's a hole, it's removable, we call it discontinuity. It's easy to fix that.